Today we're going to talk about inheritance, which is one of the most powerful ways for us to reuse code in Java. Just to remind you, in Java, all classes are part of this immense hierarchy where object is at the root. So everything is, in some sense, an object. Okay, every class inherits all of the characteristics, that means the variables and the methods of the classes that are above it in the hierarchy. And a class can add new variables in addition to the ones it inherits from its superclass, from the classes on top of it. It can also add and modify methods that you inherit too. Okay, so a picture may make this easier to understand. In this figure, we can see a part of a class hierarchy that has object at the root. And by the root, we mean it's at the top position in this sort of upside down tree. Below object, we can see its subclasses, AAA, BBB, and CCC, but we actually only show one direct subclass, AAA. Because AAA is immediately below object, we would actually say that AAA extends object. AAA extends object. It's the immediate subclass. Okay, in the same way, BBB and CCC both extend AAA. They're immediate subclasses of class AAA. Now, a class can have multiple, as many subclasses as it would like, but every class, except object, of course, which is at the root, every class except object has exactly one superclass. AAA has multiple subclasses, BBB and CCC, but it has only one superclass, which is object. Likewise, CCC could have as many subclasses as we wanted to give it, but it has only one superclass, AAA. Now, the descendants of a class would really just mean that class's subclasses, plus their subclasses, and their subclasses, and so on forever and ever and ever through the hierarchy. So as our first sort of poke at the idea of inheritance, as an illustration of inheritance, we'll implement a class wheel, which is a subclass of circle. Now, a wheel is really just a circle with spokes added on. So most of the code that we need to implement a wheel is already in the circle class. I'll first present really briefly the code, and we'll show the testing of the code. We'll go through some of the comments, and then we'll do a detailed explanation. Okay, so here we have the code for the wheel class. We won't go over it in detail right now. If you'd like, pause the video and pick through it a little bit, see what you can find, but we'll do a bit-by-bit analysis shortly. Key thing we can see here is wheel extends circle. So a wheel is a direct subclass of circle. Likewise, we can see some wheel-specific things, for instance, the spokes instance variable, which circle didn't have, but a wheel does. And what you can assume is that a wheel inherits all of the variables and methods that a circle would have had. But let's skip right ahead to our test of the wheel class. Okay, here we can see all we're doing in this test shapes class in the main method. We're making a pen, we're making a circle that will point a shape variable at, and we'll make a wheel that will point another shape variable at, and then we'll draw both. And the end result is something that looks like this. This is in the code example. You can try it for yourself if you would like. But let's dive into a more detailed explanation of the wheel class so we can really see how the inheritance works. Okay, first things first, in the class header, we can see that wheel extends circle. And again, this means that it's a subclass of circle, and it inherits all of circle's instance variables and methods. Okay, now we don't have the implements shape statement here, and that's interesting. Okay, we don't need it because circle implements shape and wheel extends circle. So wheel inherits that shape interface through circle. That's a subtle thing that just happened there. Okay, if we look at the variable spokes, which tells us the number of spokes in the wheel, that's the only variable that's declared in this class. The other variables, which are x position, y position, and radius, they're all inherited from circle. But if we want to reference these variables in wheel methods, we have to modify the circle class just a little bit. In circle, we have to declare those variables to be protected rather than private. This distinction basically just means that circle's descendants, any class that's down below it in the class hierarchy, circle's descendants can access those variables, but they're still hidden from all other classes. You can see what that change looks like here. We just have, instead of private double radius and private double x position, y position, we have protected double radius and protected double x position, y position. So that's a third visibility modifier for us. So far we've seen public and private. Now we're adding protected, which basically means this is private except to me and any of my descendants. Now, methods can actually be protected also, just like a method can be public or private. We won't have any reason to use protected methods here, but it works the same way. Protected method is also accessible only to the descendants, but not to anyone else in the hierarchy, only to that class and its descendants. Okay, now the constructors in the wheel class, they explicitly initialize the variable spokes. That's the new instance variable we added to the wheel class. But we use the constructors in the superclass circle to initialize all the other remaining variables. That's x position, y position, and radius. The way we do this is by using the keyword super. Super activates the constructor that we want in circle. In other words, it activates the superclass's constructor. And whatever parameters we pass it, those determine which constructor in circle in the superclass will be called. Now, when you use super this way, it has to be the very first statement in the wheel constructor. So the fact that you see right here, the very first thing that happens in the wheel constructor is the call to super. In this case, we're calling the default constructor of the circle class. That's not an accident. If you're using super to call a constructor, it has to be the first thing that happens. Then you can handle everything else, for instance, initializing spokes. It works slightly differently in other methods other than the constructor. We can use the keyword super in other methods other than the constructor, but it can appear anywhere inside the method. Now, the other thing that's different is it doesn't take the form of just the word super and then a parameter list. We'll have it take this form, super dot, and then whatever superclass method you want to call and whatever parameters you want to pass. So you can see an example here. If we want the wheels draw method to work substantially the same as the circle method, well, we can say, look, go ahead and call the superclass's draw method, go ahead and call circle's draw method, and that'll draw a circle, and then all we have to handle is how we draw the spokes. This just means that the draw method in circle gets activated, and as soon as it's done running, we'll come back and finish up our work here with the rest of this code in the wheel class's draw method. Now note, if you wanted to run the current class's method and not the super class's method, you can either leave off any kind of super or anything like that, so just call the method by its name by itself, or you can explicitly write this dot and then you call the method name. So super dot whatever method gives us the super classes, and either not using anything before the method name or explicitly saying this dot whatever gives us the current class's version. Okay, you might have noticed that not all of the shape methods are actually implemented in wheel. For instance, we haven't implemented a new area method here, and we haven't modified the area method that we got from circle. Okay, the reason they don't show up in the wheel class is that they are inherited completely unchanged from circle. So if we ask a wheel object to move, we just call the exact same wheel object in circle with no changes whatsoever. Some methods can be modified too. So whenever a wheel object has to respond differently to a method call than a circle object would, we just redefine that method inside the wheel class. Okay, draw, like we saw before, and toString are both good examples of this. Whenever it's convenient, the redefined method, the new one in the current class, can just use the super keyword to call the old version of the method from the superclass and then add any additional behavior onto the side. But you don't have to. We did that in the draw method, but in the toString method, we don't do that at all. We just have a new string that we build and we return that string. You don't have to use super. Okay, and finally, you might have noticed that there's some extra methods here. Okay, a subclass very often has methods that do not actually appear in its superclass. These are methods that are added completely. An example here is setSpokes, right? setSpokes doesn't mean anything to a circle, but it's a behavior that is sensible to have for a wheel. So it gives us a behavior that's a little bit more specific than you'd find in circles. So we can feel free to add new behaviors to a method. Okay, now because wheel is a subclass of circle, it automatically implements shape. That's what we said before. So that means we're actually allowed to take a variable of type shape and instantiate it as a new wheel object. And then we can use any shape method that we want. So here's an example of that. We can say shape, some shape equals new wheel. So again, we're pointing a shape variable at a wheel object. And then we can call any shape method using that shape variable, knowing that we'll call whatever version of it is implemented in wheel. But there's some complication here. Some shape can't run wheel methods specifically. For instance, the set spokes method. That's not a shape method. So if we have a shape variable, it doesn't matter that some shape actually points to a wheel object. It's a shape variable, so it can't run a wheel method. From the compiler's perspective, some shape can only call methods that are in the shape interface. Okay, now there's two ways around this. One way is to just declare a wheel variable to begin with. So don't even bother making a shape variable pointing at a wheel object. That may sound tempting and maybe it'll work a lot of the time, but in general, it is our preference, a sort of religious preference, to declare interface variables where possible. The other way around it is to cast our shape variable to a wheel whenever we want to use a uniquely wheel method. Okay, again, that just means just like before when we could cast a double to an int or an int to a double or in different directions, we can also cast reference variables from one type to another. So here you can see we start shape v2 equals new wheel, and then if we want to run the set spokes method, all we have to do is temporarily cast v2 to a wheel, and then we can call this wheel-specific method set spokes. Now be careful. You don't want to cast a variable to a type that is actually in conflict with its actual identity. This is going to give you an error, a runtime error. So here's an example of that kind of mistake. If we had a shape variable s and we pointed it at a circle object, and then we tried to cast that shape s to a wheel, well, we can't do that because the object that we're working with is a circle. So we can't cast it to a wheel and try to use a wheel method on an object that is really a circle. We're going to see more examples of this in the next lecture, so don't worry if it's slightly confusing to you. Just know that if you have subclass-specific methods, you've got to cast any interface or higher-up variables to that subclass so that you can call those subclass-specific methods without having a problem. Okay, before you close up shop, here are the things you want to think about. What's a class hierarchy? Give me an example of one. How do we get one class to inherit data and behavior, that is variables and methods, from another class? How does super work with constructors, and how does it work with methods other than constructors? What is protected? Well, what does it do? How do we use it? What is it for? What does it mean? And tell me what the error is in the following little code chunk, shape s equals new wheel, s.setSpokes 5. That's it for right now. More on this in the next lecture.